In this lecture, we'll both add and remove chunks to our level using lists. Both lists and arrays are both considered collections inside C#. However, they've got some pretty key differences. At the very top of our level generator class, we had to define our array as having 12 elements inside of it right away. However, lists have what's referred to as a variable or a dynamic collection size. We can constantly be removing and adding from that collection as needed. Generally speaking, arrays tend to be a bit faster. They're both pretty easy to use, but when it comes to flexibility, lists by far take the cake every single time. Now, there are definitely still some use cases on when you'll still want to use arrays moving forward, especially as you continue to expand your knowledge with inside of Unity and C#. But when in doubt, just list it out. Most of the time, it can often be easier to just use a list. Let's head back into our level generator class and convert our array into a list. At the very top of our class, instead of using an array, let's actually define a list. I'll actually just comment this out for a second just so you can see the two side by side. To define a list, we type list, open angle bracket, and then the type of list that we want to create. In this case, we want to create a list of game objects. Closed angle bracket, and then just the name that we'd like to call our list. So we'll just use the same name, chunks. And then similar to up top, we need to initialize this list. Now, you don't need to technically initialize it right away, but you can't properly use the list until it's initialized. So the common syntax to do that is to type equal, new, list, and then just the type of list that you're creating, open and close parentheses, to initialize our list that we just defined. With this new list created, let's go ahead and just delete this line here and go refactor some of our code to use our list instead of an array. So let's see. So let's scroll all the way down here to where we actually have a compilation error. Instead of using chunks.length, we actually want to use chunks.capital_count. It acts basically the same as .length inside of an array. However, .length inside of an array will always return the amount of elements inside of the array, whether or not they're empty. Chunks.count will just always return the amount of elements inside that current list. Let's hop back into Unity just to make sure that's still rigged up correctly. Great, everything seems to be working as intended. We've just converted our array into a list. We can now more dynamically add and remove chunks from that list. Let's hop back into our level generator class and actually try some of that out. Let's start with removing a chunk every single time it passes our player. I think an appropriate place to do that is in our move chunks method that we're already calling on update. Let's just actually check if it's a certain distance behind the camera, not necessarily the player, then we can just remove that chunk. To do that, let's just grab each individual chunk and actually cache it as a reference for now. So game object, we'll just call it chunk and set chunk equal to chunks, open bracket, I, just to grab each individual chunk just as we did on the line below. We can actually just use this cached reference here and just replace chunks, open bracket, I in the line below. Great. We can now actually use that reference just to check if that chunk is a certain distance behind the camera. And if it is, well, let's just delete it. So we can do that using a simple if statement. We'll just say if chunk.transform.position.z is less than or equal to our camera.main.transform.position.z minus some sort of offset. I think a reasonable offset to use is actually just the chunk length, just to make sure it's not actually deleting within our player's view. We can actually just minus our chunk length, just to give us a nice natural offset. If that condition is met, well, then not only do we want to actually destroy the game object itself, which is just destroying that chunk.gameObject, so we'll just destroy that chunk, but we also want to remove it for our list. Well, because we can dynamically actually change our list, it's as easy as going into chunks, our list that we've defined at the top of the class, .remove this specific chunk inside of our for loop. And it doesn't matter where that element chunk is in our list. It's just going to go through that entire list, find that specific chunk, and delete it. Before we hop back into Unity, let's actually scroll up to see what else we can refactor. Inside of our spawn chunks method, where we were previously adding to an array, now that we're adding to a list, we don't actually need to mess with I at all. Very similar to removing an element from a list, we can actually just go into chunks and type chunks.add, and then just directly add our new chunk that we just instantiated. Nice, let's hop back into Unity and see if that works. All right, let's hit play and see what we're looking at here. Zooming into the very back of our player, you can see with our main camera highlighted, every single time our chunk gets a specific distance away from our camera, not only is it deleted from our scene, the entire game object is both deleted from our hierarchy, but it's also being deleted from our list. If you go into level generator, go back into debug mode, you can now see our chunks list is indeed empty. Working as intended. I think the next natural step would be to get chunks being added into our list and it being instantiated at the front of our level. And I think that introduces us to this lecture's challenge nicely. Instantiate and add a new chunk to our list of chunks every single time a chunk is destroyed. Use chunks.add to add an element to a list. The challenges are getting trickier, aren't they? This one's going to take a few different steps between adding some new additional logic and refactoring some of the methods we already have. So just a bit of a hint, you'll have to refactor how you use our calculate spawn position Z method. The time to learn and grow as a programmer is the time that you really scratch your head and try to solve things on your own. Give this one an honest effort. If you can't solve it on your own, don't even worry about it. Come back here when you've given it a try and we'll go through my solution together. Pause the video. I'll see you here shortly. Let's hop back into our level generator class, shall we? I'm going to go ahead and exit debug mode and hop back into our level generator script. Let's start with extracting some logic from our spawn chunks method to not only instantiate just our starting chunks, but just one each individual chunk at a time, so we can actually reuse that method as needed. I'm going to take all 4 of my lines here in between my for loop and extract this method. I can just call this something like spawn chunk singular, just to spawn each individual chunk. I'm sure you could go about solving this in a few different ways, but I'm actually not going to pass through an integer or I at all. I don't really think I need it anymore. I can actually calculate our new spawn position Z by just using our list. So I'm going to also make sure I delete the argument I from calculate spawn position Z. And then also scrolling down to our calculate spawn position method itself, just delete this parameter I. I don't really need it. I don't want it. Instead of using I, I'm going to use the count from our list, basically the amount of elements that we currently have in our list. So I'm going to replace I with chunks.count. And if chunks.count is equal to 0, great, we just want to return 0, which is going to be transform.position.z. And if it's not 0, everything else, I'm going to actually refactor this to be a little bit different. Let's just comment this line out for a second so we can use it as a reference. And I'm going to set spawn position Z equal to the very last element of our chunks list. So the way we actually get that is with chunks, open bracket, chunks.count minus 1. Chunks.count is always going to return the number of total elements inside of our list. So to get the very last element of that list, you just subtract it by 1. Now that we have the very last chunk in our list, we want that specific transform.position.z value with that specific z float value of our very last chunk in our list. I'm then just going to add our chunk length to it to get the new position of the new chunk that we want to spawn. Nice, with that set up, I'll go ahead and delete that commented out line above. Now that we have a method where we can spawn each individual chunk, our spawn chunks method is just going to spawn the starting amount of chunks that we have set as a variable up top. So I think it'd be a little bit more aptly named if we renamed this method to something more similar to something like spawn starting chunks, just to be explicit in what it's actually doing. That way, if we scroll back down to our move chunks method where we're properly removing a specific chunk from our list, after we destroy the most recent chunk, we can just, well, create a new chunk. So let's just call spawn chunk. And with that, I think we're all set. Let's actually hop back into Unity and see if that works correctly. Let's hit play and give it a whirl. Let's not only keep our eye back here, we've still got each individual chunk properly being destroyed. That's great. But if we zoom all the way out, every single time each individual chunk is being destroyed from behind our player, great. At the very front, we also have a new chunk being instantiated and added properly to our list. And just like that, we have an endless runner. It's not really doing anything necessarily, but we're running infinitely. Well done on this lecture. When you're ready to move on, I'll see you on the next one.